Module 5, the muscular system, histology and physiology. How a muscle fiber relaxes. In the previous section, you learned how a muscle fiber contracts. If you understand that process, the process of how a muscle fiber relaxes will be easy to learn. First, in order for a muscle fiber to relax, the stimulus or action potentials moving down the axon of the neuron have to stop. If they were to continue, acetylcholine, or ACH, would continue to be released into the synaptic clefts, and calcium would ultimately be released, causing the fibers to contract. So, once the action potentials stop, ACH stops being released from the neuron's presynaptic terminal. The remaining ACH on the cell membrane gets broken down by the enzyme acetylcholinesterase. Well, once ACH is unable to do its job, there isn't anything to cause the muscle action potential. Thus, calcium ions will not diffuse out of the sarcoplasmic reticulum. In fact, then the sarcoplasmic reticulum will begin using active transport to take in and store more calcium ions for later. Now there are no more calcium ions present to attach to the troponin on the actin myofilaments. The troponin resumes its original shape, the tropomyosin rolls back over the active sites of the actin, and the myosin heads of the myosin myofilaments cannot form cross bridges. You may have heard of the term rigor mortis. Well, that's a term for the stiffening a body has after death. Scientists will say that rigor mortis has set in. This is because at death, the cells cannot make any more ATP, so active transport has to stop. Therefore, calcium ions cannot be brought into the sarcoplasmic reticulum of the muscle fibers. It then leaks out and causes cross bridges to form. Yet there isn't a good supply of ATP anymore, so muscles will not completely contract. Remember, after a power stroke, ATP has to bind to the myosin heads again so that they can let go of the active sites they have attached to. If there's not enough ATP, the cross bridges remain intact, so muscles will not be able to contract or relax. That keeps the body from being able to move, and it will then remain stiff until the muscles begin to decompose. Have you ever had muscles that felt stiff? Perhaps after a very long bike ride or a continual basketball practice where you've tried to make one basket after another. When this happens, you're experiencing a physiological contracture. You've used the muscles so much that there's no more ATP present to cause more contraction or to separate the cross bridges. The sarcoplasmic reticulum cannot actively transport calcium ions inside either, kind of like rigor mortis. It results in a temporary stiffness until your cells can recover enough to produce more ATP and allow normal muscle movement to occur. Now let's get back to describing muscle relaxing. At the point where the cross bridges are broken, the muscle fiber is still contracted. All the sarcomeres are shortened, yet there isn't anything holding them in that position, so they begin to slowly stretch out. It doesn't automatically happen, but rather it needs another force to allow them to spread open, either gravity or the contraction of an antagonist muscle, which is a muscle that performs a movement in the opposite direction.